Good afternoon, children. I know you are all deeply saddened about not having math for 4 whole days, so here's a video for you. Now, this is ID 71. Nobody get any bright ideas. None of you have this. It's a separate one I made. 71 is a number near and dear to my heart, so I am going to take this quiz. So I did. So number one, and this is the same version you have, just I changed the numbers around. All right, use a calculator to approximate to the nearest thousandths place. Okay, so you have log base 5 of 3.92. Now, if your calculator is lucky enough to put in log base 5, kudos to you. But since most of yours probably aren't, you need to load it up differently. So, you've got options. Using the change of base formula, you can do that. So, what I'm going to end up doing is taking the log of 3.92 over the log of 5. The base goes in the basement. Or if the ln button's closer, you do ln of 3.92 over the ln of 5. Base in the basement. You can almost draw a little fraction bar right along there. And your calculator has log, or it has ln preloaded into most, if all of your scientific calculators. Scrolling down here. All right, this one. Notice I have log 13 equal log 13. So I can just get rid of the log 13s because it's log equaling log. And I get 4x minus 1 equals 3x plus 7. I subtract 3x from both sides, get x minus 1 equals 7. Add 1, I get x equals 8. Now I check 8. Does it make either of those insides of my logs negative? No. So it's a good solution. Now for number 3 here. Problem I have is the fact of the following. It's not log equal log. Notice I have a subtraction. I have log minus log. So I'm going to Humpty Dumpty these back together again using our quotient property. This divided by that as one logarithm. Now I have log equaling a number. Oh man, how do I deal with that? Well, luckily in our notes, remember, I have log equaling this. This form is no longer good for me. So I'm going to turn it into an exponential, taking 5 to the second power equaling that. Remember our little 1, 2, 3. 1, 2, 3. I get 25 equals 3 over 2x. I multiply both sides by 2x. Get 50x equals 3. Divide by 50. X equals 3 over 50. Does it make any of those logs negative? No. So it's a good solution. For number 4 here, again, Humpty Dumptying it back together again. Quotient property. Then, all right. What I did here was I divided 5x squared by 5 and just made it x squared. That's legal because it's linked with multiplication. We talked about that earlier. Now turn it into an exponential because this log form is no longer good. 7 to the 4th equals x squared. Whoa, 7 to the 4th. 2401. Wow, it's a very large number. Luckily, when I'm square rooting, plus or minus, you have a calculator for this, and that's plus or minus 49. Remember, you're taking the square root, so it's plus or minus. Does it make any of my log interiors negative? No, so it's a good solution. Number 5 here. All right, number 5. Let's look at number 5. Now, number 5, Humpty Dumptying it back together again. Shouldn't be a problem now. We've done the quotient property a lot. Turn it into an exponential. Did that as well. So I have 25 equals x minus 3 over x plus 5. Now, remember we did some of these in class. You multiply both sides by x plus 5 and distribute. Like that. So now, this is an equation everyone should be able to solve. You subtract x, and you subtract 128. And now you get 24x equals negative 128. You divide, and you simplify. You get negative 16 thirds. However, no solution. Why? Put negative 16 thirds back into this problem right there. Negative 16 thirds minus 3. Oh no, that's negative. And remember we talked about you can't have a negative interior of a log base. Thus, it's not a solution. That's unfortunate. Number 6 here, again, Humpty Dumptying it back together, turning it into an exponential. Now, 9 squared is 81. Multiplying both sides here. by negative 4x minus 5. Distributing, remember they're both going to be negative. Adding 405, making it 408, and then dividing by negative 324. It's a little hard to see there because the scanner cut it off. That would be negative 34 over 27, which, guess what? Still makes that a positive solution because a negative times a negative is a positive. That's lucky for us. Now expanding. All right, number 7 here. So first and foremost, break it apart with the quotient property. Oh, where we just use those? Oh, wait, all up here. Break it apart with the quotient property. Division becomes subtraction. This isn't done yet. Take your exponents, that 4 and that 4, and drop them out in front as coefficients, and you're done. Now here, notice, did a little work here up top, because this is a review from chapter 7. So when you have a radical, you can split it up into 2 separate radicals with the same index. And remember, that index can be written as a fractional exponent of 1/3. That's a review for all of you if you have the fractions on yours. So they're all linked with multiplication, so I split them all up with addition. That's good. And that D there is good. The D is good. However, these two are not. Why? Because they have the 1/3 as an exponent. The 1/3 must get dropped out in front, and we're done. Now condensing to a single log. First and foremost, you bring, like here, remember how we split it apart, then dropped our exponents down? Well, to condense, the first thing we do is take our coefficients up as exponents. That 3 goes to the exponent of A, and that 4 goes to the exponent of B. Now division and subtraction are synonymous, so take that division right there. That's subtraction. So subtraction becomes division. 1 log out in front and you're done. Here, take that 2, throw it up as an exponent. That plus turns into multiplication, and you're done. This one's a little tricky for us. Solve each equation. How do I do that? I make the bases the same. 16 and 64 are both 4 to some power. When you have a power to a power, you multiply the exponents. So this becomes 2n. This distribute to 3. That's negative 9n plus 6. Now the bases are the same, so the exponents must be equal. It becomes a simple little solving game. Now here, this one is the item with the wonderful and glorious exponent isolated. That's my first goal. Isolate the thing with the exponent. Well, here it is. It's 10 to some power. Cool. So now I turn that into a log. Why is there no base there? Because remember, it's the common log. So you take 10 to some power equals that. So you turn it into a log. And then divide that log by 5 to solve for m. And there's your answer. That would be a 0 there, by the way, in case you're wondering. Now here, before I do anything, I've got to divide by 9, negative 9. Why? Because that item, the 11, is not isolated. It's got something out in front of it right there. So I divide by negative 9. Negative divided by negative makes a positive. Is the item with the exponential isolated? Sure it is. So turn it into a log now. This form isn't good. I need to get at that exponent, turn it into a log. If you can do this on a calculator, kudos. If you can't, change of base formula down here, or you can use ln. Problem number 1 is very similar to this. And then divide by a negative, making your answer that. Now here, first and foremost, you add 1 to both sides. Why? Order of operations. How you solve an equation. Now here, then you divide by a negative 10. Negative divided by negative makes it positive. Then from here, you turn it into a logarithm. 20 is my base of 98 over 10. You can simplify it if you want. I just didn't. Equals that. And from here, there's my answer. What did I do then? I simply took the log base 20 of 98 over 10, got that decimal, subtracted 5, and divided by negative 4. Over here, first thing I did was subtract 5 and then divide by 2. Now I have the item isolated with the exponent, so I turn it into a log. log base 19, base stays the base, of 29 over 4 equals 3.1 minus 9x. Aha, now my x is free. I can go after it. That's great for me. So then what do? I use change of base or my calculator or whatever to find out what that answer is. Subtract 3.1 from both sides and then divide by -9, and there's my answer. This hard copy of this key will also be posted on D2L, along with, heaven forbid, every set of notes you've already done. So you've got a lot to look forward to there. I look forward to seeing all these quizzes on Tuesday morning during your scheduled class period. Have a wonderful, fun-filled weekend, gang. Yay, math!